name is Siti Nur Atira binti Nasrullah and I am the project manager for Group Decametallic. Today, we will be presenting our problem-based learning project for BMKT 2423, Computer Modeling and Analysis, titled Reverse Engineering and CAD Modeling of a Manual Bicycle Flow Pump. Our group members are Alia Hazira, Muhammad Aiman, Muhammad Farhan, and Ahmad Amirul Lutfi. Let us begin. This project is centered around studying an everyday product in depth through the approach of reverse engineering. Reverse engineering allows us to study, measure, and document an existing product in full technical detail. For this project, we selected a manual bicycle flow pump consisting of 10 functional components. The entire modeling, assembly, and analysis process was carried out using SolidWorks 2005. This project is also aligned with SDG 9, Industry Innovation in Infrastructure, by promoting innovation through systematic engineering documentation.
Hello, I am Alia Hazira binti Abdul Rahman, responsible for CAD modeling of the valve head housing and cylinder barrel. The problem we identified is that manual bicycle flow pumps available in the market rarely come with complete technical documentation or engineering drawings. This makes it difficult to repair damaged components as there are no reference drawings to guide the process. It also makes remanufacturing nearly impossible without a documented design. Reverse engineering addresses this gap by providing a systematic and accurate engineering reference for future repair, analysis, and improvement. Our project set out to achieve 5 main objectives. First, to perform reverse engineering on the actual bicycle floor pump product. Second, to create 10 individual CAD components model in SolidWorks 2025. Third, to assemble all components using fully defined weight constraints. Fourth, to conduct structural analysis using finite element analysis to evaluate stress, strain, and factor of safety. And fifth, to prepare a bill of materials and cost estimation reflecting real-world product development considerations.
Hi, my name is Muhammad Amirul Lutfi and I was responsible for modeling the host, head host, and locking lever. Our project scope covers 7 key activities. We begin by measuring the actual physical product, followed by producing concept sketch for each component. We then develop individual 3D CAD model in SolidWorks. Before assembling all components together, structural analysis was performed on the assembly. A material selection with cost calculation were complete to reflect real-world product development. These 7 activities define the boundaries of our study. The bicycle floor pump was deassembled and divided into 10 main components. These are piston gun, hook stand bracket, valve head housing, cylinder barrel, air hose, locking lever, T-handle, polyplating meter, bottom end cap, and pump base. This component was individually modeled by our team member in SolidWorks 2025. Based on physical measurement taken from the actual product, every member was responsible for a minimum of 2 components.
Hello, I am Muhammad Farhan bin Mahfuz, responsible for structural analysis and modeling the T-handle and ball inflating needle. Our design process followed a structured 8-stage workflow. We started with the actual physical product, proceeded to measurement, then concept sketching. This was followed by SolidWorks modeling of each component individually. Before assembling all parts together, structural finite element analysis was then carried out, followed by the production of technical drawings. The final stage was the delivery of the complete model product. Every stage was carried out collaboratively by the Decametallic team. All 10 components were assembled in SolidWorks using 3 types of mate constraints: coincident mate, concentric mate, and distant mate. These constraints ensure that every component is fully defined within the assembly environment, with no floating or underdefined parts. The result is a complete and functional full assembly as shown on the left and an exploded view with a labeled bill of materials on the right. The assembly was verified to be fully defined, confirming the accuracy and integrity of our CAD model.
Hi, I am Ahmad Amirul Lutfi bin Abdullah. My responsible is for assembly, visual design and modeling the bottom end cap and hose cap connector. For material selection, each component was assigned a material based on its mechanical requirement. The cylinder barrel uses aluminum alloy 6061 for its height strength to weight ratio. The foot stand bracket uses stainless steel 304 for its strength under load. The piston guard uses ABS plastic for its low friction properties. The air hose uses rubber or PVC for flexibility, and the hose connector uses brass for its pressure resistance. Based on current Malaysian material market prices, the total estimated cost across all 10 components is RM35.80. Structural analysis using finite element analysis was performed on the full assembly under a 150 Newton normal force load with a fixed geometry constraint applied on one face. The simulation produced three key results. The maximum von Mises stress recorded was 156.7 megapascals, concentrated at the junction of the cylinder barrel. The maximum equivalent strain was 9.369 times 10 to the power of -3. The minimum factor of safety was 0.352, which is below the acceptable threshold of 1.0. This indicated localized yielding under the simplified concentrated load condition applied. It is important to note that in actual pump operation, the load is distributed uniformly along for inner barrel wall, which would result in a more favorable stress distribution.
Based on our structural analysis result, we propose 5 recommendations to improve the design and achieve a higher factor of safety. First, adding fillet ready at geometric condition to reduce stress concentration. Second, increasing the wall thickness of the cylindrical barrel near high stress region. Third, upgrading the barrel material from aluminum alloy 6061 to the highest strength 7075 alloy. Fourth, incorporating a digital pressure gauge for more accurate tire pressure monitoring. And fifth, improving the ergonomic design of the T-handle to enhance grip comfort and reduce user fatigue. In conclusion, this project successfully demonstrated the application of reverse engineering principle through the complete modeling, assembly, and structural analysis of a manual bicycle flow pump using SolidWorks 2005. All 5 project objectives were achieved. 10 components were successfully modeled. The assembly was completely with fully defined, made, constrained, and no floating parts. FEA was successfully conducted, producing stress, strain, and factor of safety result. An engineering drawing were produced for all components and the fully assembled. Overall, reverse engineering was achieved, meeting all 5 project objectives. On behalf of Group Decametallic, thank you for your attention. We welcome any question.